Hi, this is a supplementary lecture on Introduction to Mathematics of Interest for the Executive Black Belt class, Straight Line. Okay, so essentially what we want to discuss in here is not to go very deep in financial calculations, but to just make you conversant in a few different areas. And mostly these areas involve understanding the time value of money and learning a couple of key ways of looking at that. Our objectives are, after completing this, you should be able to calculate present and future values of sums and annuities, of sums of money and annuities, and most importantly, understand and use the net present value function and the internal rate of return function. And we'll actually do our examples in Excel, so you'll see how it works in action. And though it's not necessarily important for every black belt to be super duper financial person, what is important is that you become relatively conversant in these, particularly these two ideas, net present value and internal rate of return. So where do we use this? Well, we're going to mostly use this in our reasoning to make the business case, and also at the end of a project to communicate benefits, what we actually did, the benefits of what we actually did, and then to be able to also make future recommendations. Now, in my work as a Master Black Belt, I'm often called to assess a process in a number of different project opportunities, and these sorts of these two functions, internal rate of return and especially net present value, come into play when I do my evaluations. They're by no means the only things I look at, no way, but they are important tools in your reasoning about what sort of things ought to be done and could be done and how much value they'll deliver. So let's get to it. So the first and the most important concept in here is that money changes value over time. And there's a reason why, when I was a kid, I watched the cartoon Popeye, and there was a character on there who would say, "I'll gladly pay you Tuesday for a hamburger today." And that was a funny joke. And the reason why it was funny, well, maybe it wasn't that funny, but it was funny because Wimpy, who's the character who was asking this, was trying to get both things. He was trying to defer his payment and at the same time not have to pay anymore and get the goods today. However, of course, money changes over time, and in fact, it usually decreases in value. Why is that? Well, there's a number of different reasons. The first is inflation. Generally, the economy increases, and so inflation happens over time. So the same amount of money will buy less a year from now, in general, than it will today. The second thing is risk. We have uncertainty about the future, and because the future is uncertain, a bird in hand is worth two in the bush. Okay, and finally, there's a third thing, and that is that most companies, as well as most individuals, have a preference for liquidity. That is, to have cash available so that we can use it very quickly. If you want to buy a guitar or you want to invest in an employee or something like that, it helps to have the cash on hand. So assets that are more liquid are to be preferred. So we want to help to conserve cash. Okay, so basically there's two definitions here that we're going to think about, and one is future value that we're going to care about, and I'll give you the formulae for calculating them. One is future value, and that is how much will an investment today be worth at a future date. For example, one of these will be investing in a Lean Six Sigma project. How much is that worth today? Second thing is present value. What am I willing to invest today in exchange for a promise to receive a larger sum in the future, like a bank loan on your house or something like that? When the bank gives you a bank loan, they're getting future payments that are much greater than what you're putting down, and you're getting the house right away, right? That's the trade-off. Okay, so just very quickly, I'd like to show you the formulae. There are formulas for this on pages 98 and a few of the other slides, and we'll just kind of go over the basics of what these look like. So here's the future value, here's the future value calculation right here, and you'll see it takes P, the principal. So you know, if we invest in $100 today, if I invest $100 in something, and I let it go over a year, that would be the number of periods, at 6%, I would have $106 a year from now. Okay? So if I let that happen again and again and again, it's just like multiplying this quantity 1 plus 1 over and over and over, multiplied by this principal. So again, the future value, say in 2 years, would be P, 100, times 1 plus 6%, I, raised to the nth power, 2. So that would give me a larger value. Okay? So and let's just write that out. So if I had $100 today, if P were equal to 100, and let's see, and the interest rate I were 6%. At this writing, it's nowhere near. Okay, and I wanted to wait n equals 2 years. My future value after 2 years would be equal to 100 times 1 plus 0.06 to the second, which is, of course, equal to 100 times 1 plus 0.06 times 1 plus 0.06. Right? That's what 6% means. It's 6 divided by 100. All right, so that's how that would work. And of course, after 1 year, that would be $106. After 2 years, I have 1 plus 0.06. Okay, I'm going to square that, and I would have $112. Okay, so it turns out that F2 equals 100 times 1.11, I'm sorry, 1236. Okay, so that's about $112 and 36 cents, I guess I'm going to put that in, after 2 years. So that's basically how that works, right? Okay, and we can also derive it the other way around. We can calculate the present value given what the future value is as well. Now, what happens if we keep adding to that? Well, if you keep adding to it every year, year after year, you get what's called an annuity. And we won't go through this calculation, but you can plug it in and here's what the annuity formulas are. Okay, so we're not going to go over these formulas too much or do an example. You can plug in your own values if you want to do that, and that's fine. But do keep in mind that we're covering ourselves for the first case, which is simply the first case. Wow, that was interesting. The first case, which is simply I have a fixed amount and I let it accrue interest over time. And the second case, which is I have an amount and then I add an amount over time to it. So I have a series of cash flows over and over. And that's the key concept that we're going to go into now. So we're going to do all this in Excel, as I'm sort of indicating on slide 100. And let's just get right to it. So the two formulas and the two concepts that I'm going to get are NPV, okay, and I'm going to write the Excel functions right here. Net present value, or NPV, and what this is in today's dollars, and this is the concept that works. In today's dollars, if we think about a series of cash flows that will occur over time, right, which is very similar to what we're going to say our project is delivering. If our project delivers, let's say, for example, $100,000 annually over the course of 3 years, then the net present value would say what it would ask the question of, what is the value of those 3 cash flow payments or cash flow amounts of $100,000 over the next 3 years? That's what we're trying to do, okay? So again, it's the value in today's dollars of a series of cash flows at different points in time in the future. Okay, now, one of the things that NPV requires, as we'll see in just a moment, is we need to know what are each of the cash flows. And I'm going to write the word net here because in some cases we're going to have to spend money to get money. Okay, so each of the net cash flows. And the second thing is the company's weighted average cost of capital. Now what is this? Well, this essentially accounts for that all those things like the risk of what's going to happen, but what it really amounts to is the company's ability to obtain money. So if the company can obtain money cheaply, then often you'll have a low weighted average cost of capital. If it's difficult for the company to get money, raise money from banks or investors, then you'll have a higher one. Now personally, I like to be very conservative or fairly conservative, and I use a fairly high weighted average cost of capital. Generally speaking, the higher the number here, 14, 15, 18%, the less of a likelihood that you'll want to invest in something. The more conservative it will be, and we'll play around with that, and you'll see what I mean in just a moment. Okay? All right. The second question, or the second one that we care about is called internal rate of return, or IRR. I guess I've already got that one in the right format. In Excel, it'll be IRR. And one of the things that people seek to do is they say, well, you know, since the weighted average cost of capital is tough to know exactly, why don't we just develop a formula that doesn't have to have it, and bingo bango, you get the internal rate of return. So there are some advantages of internal rate of return, and that's the biggest one, that you can actually evaluate it without having to know the weighted average cost of capital. Now, what is it? Now, I've seen it called the discount rate and all this kind of stuff, the amount that you have to discount the interest rate. You know, the way that I think about it most is that I think IRR is the value of the weighted cost of capital such that the net present value of a project would be zero. And you'll see how this works. Now, a large IRR is good. 15%, 20%, 40%, 100%, 200% internal rate of return is good. So I'll tell you what, let's take a look at an example, and we'll see how we can use this in our statistical reasoning. Now, I'm going to do it in Excel because on this next page, this is the example that I want to use, but there's a reason why I'll do that in Excel, and the reason is because this is wrong. What I've inadvertently done in terms of this calculation, if you're going over it yourself, is I used this value as well. And so that gives you a slightly erroneous result. So we'll come back to this in just a moment. Okay, so let's take a look at how this, of what this is in Excel. You'll see that what I've got in here is the same values that I had on the spreadsheet. So imagine this. Imagine this is your project in terms of the benefits it's going to deliver year 1, year 2, year 3, year 4, year 5. Whatever your project is, it could be installing a piece of software to make call center actions less costly. It could be investing in a project that would decrease the amount of time that it took to collect on invoices. Whatever it was, let's say that this was the predicted value in year 1, year 2, year 3, year 4, year 5. If you're struggling with this, think of this as the following. Suppose this is 2014, then this would be 2015 and 2016 and so forth, all the way through to 2018, right? So it's a series of cash flows into through the years. All right, in column or in row 3, we've got the benefits. So you can see in the first year, we're saying it's not going to deliver any benefit whatsoever. In the second year, I'm going to go back to year 1, year 2, and so on. In the second year, it'll deliver 150, third, 200, and so on. And here what we're doing is we're putting in the costs. Now this is actually pretty typical. You'll have a lot of upfront cost and then a maintenance cost. You can see that the assumption here is essentially a 10% maintenance cost. In the third row, we've got the net benefit, which is simply the benefit minus the costs. So you can see in the beginning we were losing money on this, and it's only in year 2 that we start making money, and year 3 that we become cash positive. Okay, so let's go ahead and let's see what would be the net present value of this. Now I'm going to go ahead and show you by typing in, and so you can see my screen, I'm typing it in, the net present value, and we're going to assume, just for the moment, that the weighted average cost of capital for this firm is 15%. You'll see why it doesn't really matter in terms of our evaluation what that is in just a moment. Okay? So NPV, NPV of, and now we have to select the rate. So I'm going to select C7, comma, and now I enter in the cash flows that I care about. So I'm going to enter in these cash flows, Y1 through Y5, and that is, let's see, C5 through G5. Okay? And paren, and you'll see I will get the same value right there. Okay, got it. So that's what NPV is. Now the interesting thing is, just to give you an idea, if we put in a 0, we just get our total value of the project. It should be 490, and bam, it is. That essentially means that we don't incur any cost. There's no time value loss of money. Okay? If we assume a 5% weighted average cost of capital, the value of the project starts to go down. And this is important, right? Because we're thinking about 5 years in the future, cash flows. That's certainly worth less than it is today. That $135,000 in year 5, that cash flow, is not worth $135,000 today. It's worth considerably less to us. Okay, so let's put this back at 15, and you can see it goes down to 266. All right, now let's do the same thing for internal rate of return. And I'm going to show you that 107 is not the right answer. We'll plug in the right answer. All right, so the way that this works is IRR, it's looking for values, and so we're going to put the values of the cash flows that we care about. Notice I did not select that last one. Okay? All right. The last one is just a total. All right. So actually, I am going to select it. Let's see. Whoops, I got it here. Try that again. Equals IRR, and if I select the whole thing, you'll see that it goes to 107%, and there it is, 107. Okay, but remember, we don't want that last one, so I'm going to take that out, and that gives me 97% IRR. So that's actually a pretty high IRR, and so let's correct that one. This really should be, should only go through G5. There we go, 97%. Okay, now let's examine this for just a moment. What would happen if I put, the question is, what would happen if I put the weighted average cost of capital to 97%? Claim is that net present value goes to 0. And it does. In fact, it's pretty darn close to 0. Look at that, 33 cents below. If I go to 96%, it'll be just above. So there it is right there. So the point I'm trying to make is that internal rate of return is the value such that the net present value is 0. Okay? So that's it. Now, what are the advantages and disadvantages of either of these? Let's go back to the our show here. Let's go back to the show. So this should be a 97%. Okay? Just in case you were trying. We should not include that in the IRR calculation. Okay, so what are some of the advantages and disadvantages of NPV and IRR? Well, the main disadvantage of net present value is that you need that weighted average cost of capital to have some sort of real number. But as we saw, our value of reasoning isn't impaired by that. The big disadvantage of the internal rate of return is that when you're comparing a bunch of projects, it doesn't necessarily show you the total amount. So just picking the highest IRR can get you into some trouble. All right, and to show that, let's go through the exercise that's given on page 107, which involves looking at 5 different projects. Okay, so on this one, we've got 5 projects, and the net benefits are all given. Okay, and we want to assume that the projects in the table were all done in sound fashion. okay, or would be done in sound fashion. If one and only one project could be funded, which project should get preference? Okay, how about if two? So let's take a look at how we might evaluate it. There's a number of different ways that we could. Let's take a look at how we might evaluate it. Here are the projects. Here are the projects that are there, and you can see the different values and the workflow. So just thinking about it for just a moment, we've got one that improves operations workflow, which is going to deliver benefits through 2017. They're all losses for this year, but next year these are the pluses, and the following year, and the following year, and the following year. Okay? So one way that you can evaluate this would be to calculate the NPV. So let's go ahead and do that. And again, for grins, we're going to say the weighted average cost of capital. Let's just put that at 15%. And I'm going to go ahead and calculate the NPV for each of these. So there's the rate. Okay. And if you're not used to this in Excel, what I'm going to do is I'm going to bind that cell by putting dollar signs in front, and I'll be able to copy it down. And now the values. Okay, I didn't get a total this time, so that's good. Okay, so that one's worth 311. Is that right? $311. Okay, looks like it is. Yep. All right, and we'll copy that down so we can see what the net present values are of all of these. All right, so if we're going to say that there's no time value of money, this is how much each of these would deliver. The first one, $600. We can think of these in terms of thousands, right? The second one, $170, and so forth. So we might think that, oh, well, here are the positive things that each one is going to deliver. And so if we only have a certain amount to invest, we'll put, if we're going to invest in one project, maybe this is the right one to invest in, the sales force effectiveness, because it's going to deliver the highest net benefit. Now, there are a couple of other ways of looking at this, but again, net present value helps clarify, at least to some degree, what this is. You can get break-evens. That's another way of looking at it. So if we're going to only pick one, we might pick this one. Now let's think about the second thing. What if we were going to pick two? Well, we could say we'd pick these two. This is an R&D capital expenditure, but let's look at this one. If we pick these two, this one has a pretty good net present value, but it's not going to deliver benefits, positive benefits, until year 4. And then, even then, it won't break even, and it's expected to really go through the roof in year 5. So, again, there's a lot of uncertainty. Net present value is maybe not capturing all of that, but that's something that you can note. All right, let's take a look at what internal rate of return would be. But let's take a look at, before we do that, let's take a look at the next, oh goodness. Here we go. Let's suppose instead that we use the rule, the highest IRR gets funding. And let's see what there are issues, if there are any issues with this. Again, I've gone to the wrong spreadsheet, and here I am. Okay, so let's put that in, IRR. Now, IRR helps if you make an initial guess, but even if you don't guess, it'll guess 10% for you, so you're usually covered in that. Okay, let's just go ahead and select this, hit the return button. That's my IRR, and there we go. So notice that when I change this, IRR will not change. It's always the same. Look at that. Okay. It's back to 15. Okay. So if we were going to use the rule, the highest IRR gets the project. If we were going to only select one project, it would have been this HR system, which has a very high internal rate of return. Now, this is a very interesting thing because you might say, well, this is giving some conflicting information. Well, maybe. It's just looking at a thing two different ways. Here, this has a very high return on investment. So I don't have to invest that much. I don't lose that much in year 1. But in the end, I don't really gain all that much either. It's really only worth $100,000 over 5 years. On the other hand, it is a pretty sure return. So maybe it would be worth investing this if we knew, for example, if we knew, for example, how many people it was going to take to really make this happen. So, but again, it's going to return pretty quickly. All right, so hopefully these tools are giving you at least some idea about how you can reason using these things. Net present value and internal rate of return, they're helpful to look at both of them at the same time. For example, these two, or this particular project, looks like it's a winner in both senses, and it also has a break even after the second year, right? So see, this does better than break even, but this breaks even after the second year. So this is a pretty good bet if you're pretty sure of these numbers. Okay, so hopefully that was hopefully that example was helpful. Well, we've come to the end of the section, and now is the time for you to write down what are your key takeaways of the section, what are the questions that you can answer, and how you can support business improvement with this section. Okay, the important thing to remember is that money does change its value over time, and that we have now two additional tools that we can use to help evaluate that. Net present value, which tells me the value in today's money of a series of future cash flows, and internal rate of return, which is the rate at which, the discount rate, or the weighted average cost of capital at which the net present value is zero today. Okay? Hope you enjoyed this and hope it was helpful. Take care.